and welcome to the AQUALIS Sustainable Water Compliance Summit session titled A Digital One Water Approach to Collection Systems and Asset Management. I'm Bob Crossan, Group Editorial Director for Endeavor Business Media's Water Group. To begin, let me explain how you can participate in today's event. First of all, if you have any technical difficulties during today's event, please put your question into the question window, and our technical experts will help you out. We recommend disabling any pop-up blocking software or extensions in your browser, as these could cause issues with this webinar player. Additionally, we welcome your questions during today's event. We will answer as many questions as possible during the Q&A session that will follow the session, but please feel free to send in your questions at any time. To do so, simply type your questions into the question window on the side of your screen and hit the submit button. Also, please be aware that today's event is being recorded and you will be notified via email when the archive is available. At the conclusion of the webinar, you will also receive an email with a link to download your certificate, which can be used to submit for credit with Stormwater University or to serve as one professional development hour for attending today's webinar. Now, let me introduce to you today's session presenter. Dr. Jenn Baldwin is Jacobs' Digital One Water Director, managing Jacobs' integrated ecosystem of data-enabled solutions, and is an expert technologist specializing in wet weather conveyance and storage. She has more than 22 years of experience working on several multi-million and billion-dollar wastewater collection and treatment programs. She holds a BS degree in chemical engineering and a PhD in civil environmental engineering from Purdue University. So Jenn, thank you so much for being here, and take it away.
Yeah, thanks, Bob. I'll share my screen. I'm here to talk about using our digital one water approach that we're using at Jacobs to help us with collection system asset management. As Bob said, I've been in wet weather collection systems for pretty much the whole 22 years of my career, and it's one of my passions. So just going to walk through a little bit of, well, what are our current approaches to collection system asset management? Why use our digital one water approach? And get into some specific tools that we have in condition assessment, asset management, and smart sensors for insights into the operations of a collection system. So starting with the current approaches, for years and years, we've been inspecting gravity sewers by many methods, such as smoke testing, acoustic testing, CCTV inspections, and those data are coded from either by a contractor or an in-house crew, but sometimes it gets entered into the CMMS, sometimes it doesn't, sometimes it's put in GIS. But what really happens to all of that data that we're collecting? What are we really doing with the results of that? So one of the things we did at Jacobs, we said we've been doing CCTV coding for years and years. We know this is a big issue. Like the U.S. sewer O&M market is about $50 billion per year, and out of that, about $300 million per year is spent on just reviewing and defect coding CCTV footage. A lot of cities we work with aim to inspect about 10% of the system per year, and they're doing this with in-house crews or they contract out the work. That's a lot of money that they're spending to do this inspection, and it's really led to this massive backlog that a lot of utilities, we've talked to some utilities that say, I still have videotapes that I haven't defect coded. What do I do with that? Which then leads to this low visibility into the aging collection systems. The labor that we're spending on the defect coding is costly, and really that manual coding of defects can be error-prone, subjective, and inconsistent. Even though we have the NASCO PACP codes and we have trainers and certified inspectors, I can send the same video to a few different inspectors and possibly get different defect codes, depending on how tired they are or how much coffee they've had, right? So what we've really found is we can't keep up the status quo. We've talked to several clients, and most cities are finding, that they can conduct those CCTV inspections, but their personnel don't have the time available to focus on defect coding, and those methods for defect coding can be technically deficient. So what we're finding is, this impediment to this proactive approach is really, do they have the funding? Can they pay someone to spend their time doing defect coding? Do they have technical, that technical proficiency for that? Or it could just be a lack of strategy. Does the utility really have a strategy for how they want to do their condition assessment and their asset management? The other thing is we found that, in about 1,000 linear feet worth of sewer video, 30 to 40% of that time is spent doing the defect coding. What this led to us at Jacobs is some digital solutions and really our digital one water approach. So I want to take a little bit of a step back and walk through, what is digital one water? What do we mean by that? And really what it is we have, big data. We have tons and tons of data. At Jacobs, we operate and maintain facilities, and we found that we were using probably only about 10% of the data that we were collecting. So with our digital one water approach, we're taking these tools to transform that big data into actionable information. Can we do flood prediction or warning? Can we, do energy and chemical use optimization? Can we look at predictive maintenance? We have all these possibilities now. And we have the computing power now to actually do that. And what that has led us to is this integrated ecosystem of data-enabled solutions. So, how can digital one water approach, how can it really assist today's utilities? What we're finding is a lot of utilities are struggling with the same thing. They have more stringent regulations, aging infrastructure, staffing pressures, and shrinking budgets. I'm going to focus on staffing pressures because that's something we see where the digital solutions can really help our utilities out, because there's a couple of things happening. First off, we have a lot of retirements happening in the water industry. And you have these operators that have been working at a plant or out in a collection system for 20, 30, 40 years that have all of this knowledge that they're collecting, and it's in their heads or it's in spreadsheets or it's in a notebook. How do we take the knowledge that that person has and apply it to the next employee up? And additionally, utilities are finding that it's just hard to retain staff these days. It's more, the job market's competitive, and sometimes utilities, the pay may not be exactly as much as the consultant might pay or something like that. So how do you retain your staff? What I'm finding is that these digital solutions have really attracted not just the younger folks, but also, some people who are more in the middle of their careers or towards the end of their careers. They're saying, oh, wow, this can really help me do my job more efficiently. And now I can be more proactive and get through that backlog of work I've been trying to get through for probably the last 5 years, right? So it's really been super helpful to see how these digital solutions have been able to help water utilities, especially with that staffing pressure item. So I'm going to get into some of our digital tools that we have at Jacobs. The first is related to sewer condition assessment. Like I said at the beginning, this was something that we found our digital tools could really help us. I'm in Knoxville, Tennessee, and the folks in our Knoxville, Tennessee office, actually, when I started with Jacobs, they were this kind of younger staff, and they would spend probably 90% of their time coding, reviewing CCTV video and coding, doing the defect coding. And I was always like, wow, how do they spend all their day watching sewer video, right? So this is amazing to us. Now we can apply artificial intelligence to automatically detect those defects in the raw videos. What we get out of that is an industry standard output. We produce an accurate PACP database that's usable in any of the pre-existing workflows or CMMS or CCTV software. And we also have integrated it with our asset management tool that I'll get into. That then can provide an optimized reinspection and maintenance schedule, as well as prioritize asset rehabilitation lists. What we're finding is that I'm going to give just a little bit of a view here into what we call it our Dragonfly tool, what our Dragonfly tool does. So this little video can't really replicate this in real life because the AI tool is working very quickly, right? But we've shown that we have the original inspection video at the top left, and then we have some of our algorithms running at the top right and bottom left, where we're saying, oh, okay, I can kind of see a heat map of here's a defect. I can see where I've got some anomalies that I'm detecting. And then lastly, I'm doing my defect labeling. So basically, our solution, it's web-based solution. You upload the videos along with that PACP database or some metadata that tells us where the pipe is in the world. And from that, we create this PACP database using the AI tool. So what we found, we've been talking to many of our water utility clients, and what we found is that really the utilities can utilize this automated defect coding for several things. We can use it to process historic data. Like I said, if you have even videotapes, as long as you can digitize it, we can still process that historic data. And what that can help with, if you've done a CCTV video of the same pipe, let's say 5 times over the last 10 years, then you have that history of the defects in that pipe as well. And with the Argon insights that you get, then you can see, is that defect getting worse? Do I now need to put this on a rehabilitation schedule? Do I maybe need to replace the pipe? Or am I simply just going to go reinspect it? We've also found that utilities are having us correct quality issues. They'll send us data that's already been defect coded and say, can you run this through Dragonfly and see what results we're getting? I'll have some case studies that show how that works. And we can include it in an in-house process or add it to a contractor SOP. So this case study to the right actually shows how we can correct the quality issues, right? It shows this 12-inch 55 clay pipe with the defect codes that were provided by manual coding on the top or the automated coding on the bottom. And what we found is we really get more nuances. You can see we just had 3 defect codes, cracked, broken, or protruding. Whereas the AI tool was able to find these nuances and say, well, actually, no, some of these are deposits or debris. Some of these are the connection seal. So it's really helping to refine that defect coding as well, which then helps the utility know more about what's going on with that pipe. Here's also a side-by-side comparison of our Dragonfly tool. We had a large municipality in the US that piloted Dragonfly, and they compared 17,000 linear feet of that trusted manually coded legacy data. So this was not about quality. They're saying, we feel really good about this data. We feel really good about the defect coding. And Dragonfly was able to identify some of these nuanced defects, like I said, and also the overall pipe severity levels that were overlooked. So just taking a look at 2017 and 2018. In 2017, we basically had some 2s and 3s as far as the structural grade. Once we put that into Dragonfly, we found some that were actually a 4 or a 5 structural grade. So there were some structural issues that were not identified by the manual coding. Similarly, in 2018, there were some that were coded as a 0 structural grade, when in fact we did find they were more like a 1 or a 2. So it's really able to, find these more nuanced defect codes that maybe a human might not pick up. And from this, our client was better enabled. From this, it better enabled our client to optimize their preventative maintenance and repair plans. They're able to say, oh, okay, based on this 2017-18 data where we're getting maybe some higher structural grades, maybe we might put a couple more pipes on that repair schedule. I'm going to finish up with a case study in the southern United States. We had a city that sent us 70,000 linear feet of video to review. They uploaded it to that web-based solution. We were able to provide the coding for the videos based on the video review. And then our asset management risk assessment tool was able to provide these easily read Power BI dashboards to first break down the codes that we're seeing. So that's on the right. This is my favorite part about Dragonfly and Argon, as we call it, which is our asset management tool. Within Dragonfly, you get what we call Argon Insights. And Argon will tell you through these Power BI dashboards, what is your worst defect and where are we getting the most defects? So for instance, with the 70,000 linear feet that the client sent to us, we found that the most defects they got were sags, then deposits, and grease. We could also see, though, that there were a couple of obstacles that were a structural grade 5, and there were some also roots that were structural grade 5. So we're able to drill down, and inside the Power BI dashboard, they can click and say, okay, I'm going to click on that structural grade 5 sag. What pipes are those? Where are they? They can then download that and incorporate it into their GIS and their CMMS, allowing them to really see where their biggest issues are. From there, we also used the defects. We also used the defect codes from our automated tool and gave the pipes a structural and maintenance grade. We then prioritized them for reinspection, rehabilitation, or replacement using an AI trigger. So again, we're bringing AI. We used AI to come up with the defect codes. And then with the AI trigger, what we're able to do is we said, okay, we have this structural grade. We know what the defects are in this pipe. We can look at that combination of defects in that pipe and say, based on the AI trigger, oh, this pipe does need to be prioritized for rehab, or this one can go for reinspection. We do that with some data, the metadata that's provided. So we basically use that structural grade along with a consequence of failure based on pipe diameter, pipe material, and say, okay, based on the structural grade and that consequence of failure, what is that risk of failure? And does that risk of failure then trigger us into a priority for rehab? So this client basically only had repair, reinspection, and cleaning recommendations. So now they can get that rehabilitation, that 600 linear feet that's shown here on the bottom left, into their CIP at the appropriate time. And they can also create work orders for cleaning and reinspection into their CMMS. So they can say, oh, okay, this pipe needs cleaning. We had some older data, so you can see this pipe needs cleaning in 2022 based on when it was last inspected. So maybe you prioritize that for cleaning right away. And we also had some pipes that needed reinspection in 2025, 2026, and beyond. Now we can get that into the CMMS and create work orders. So I'm going to also talk about what we call our Argon tool. So Tuscaloosa is a client that has been using our Argon tool for several years. And basically, they wanted to do a cleaning program to help them prevent SSOs, sanitary sewer overflows. So what's cool here is that this graph shows the number of SSOs by year that are caused by maintenance-related issues. So that orange line shows, how many SSOs do we have related to just maintenance issues, debris, root intrusion, grease. Once we started using the Argon tool in late 2013, early 2014, we were able to kind of increase their cleaning work orders. The cool part is actually after 2016. Yeah, they increased their cleaning work orders for a while because they were catching up. Now that they've been using Argon for several years, they've caught up. They've been able to decrease their cleaning work orders almost every year and level it out starting in 2020 and not see an increase of SSOs. So the number of SSOs has been pretty steady since 2016. That's very neat. And actually what Tuscaloosa has said is that they use Argon daily and overflows happen. And then when they review them, they were told by Argon to revisit that pipe and they just hadn't made it there yet. I think that's pretty cool. They're like, oh, okay, this has really helped us out with our maintenance related SSOs. And we figured out that really We just hadn't gotten to that pipe yet when we did have an SSO. So we're going to kind of switch the topic a little bit. What about insights into operations? So in my mind, condition assessment and asset management, CIP, are really kind of half the battle. And we're finding that, I mean, the majority of utilities in the US and around the world really are operating these aging systems with a high consequence of failure. As I said at the beginning, as Jacobs, we found we're only using about 10% of the data that we capture. So how do we gain insights when we're just inundated with data? What we've found is that we've really had to look at new ways of working, and we're combining the digital with the domain. So you create what we're calling our model office, where you're really taking the domain experts. I consider myself hopefully a domain expert in the collection system world, but whether especially, how do we help move from reactive to proactive working practices? How do we get ahead of problems before they manifest? And we have that engineering domain where we can harvest that existing data, SCADA, telemetry, monitoring data. How do we identify where we need to monitor the points of greatest risk or concern? Add new sensors out in the system where they're going to be the most impactful. From there, we get into that digital, and we really add value to that monitoring data through applied analytics. We can learn the behavior of the normal safe operation of a collection system to help us identify emerging issues, which then gives us a response window for correction. So I'm going to start with a case study with United Utilities in the UK. And this to me is like overwhelming for me in the US. United Utilities has over 20,000 sensors out in their system. They serve 5 million customers through several cities in the UK. So it's like mind-boggling to me in the US, I'll admit, to think about that. But what we've been able to do with what we call our AquaDNA solution is to visualize this data and also use machine learning to figure out where do we have issues coming up. So these emerging issues are risk ranked and the action is prioritized to get assigned to the field crews. So you can see that the legend over on the left, we have anything from no alert to impact and progress. We can also say where we've lost communications. So if we have cellular communications or if we have radio communications, we can see, oh, that sensor is not communicating with us for a while. Maybe we need to go check that out. We also have different symbology by the asset type that helps us know right away, oh, look, I've got a pump station that's in a medium risk alert. Let me click on that, see what's going on at my pump station. With this, the teams can really get ahead of the issue and prevent those problems that are impacting the customers or the environment. And man, have we had some great outcomes with this. Operationally, United Utilities has increased their proactive fixes, so they've had more than 4,000 proactive fixes. They've decreased their sewer blockages by 13% and sewer surcharges by 20%. We've also decreased lift station callouts by 25% and reduced customer complaints by 37%. So with these reduced operational costs, and we can now see, are there some reduced or avoided capital investments? Are there assets that we can increase the life of the asset just by having this monitoring and having this data available and actually analyzed for us rather than having a spreadsheet over here that says, oh, I'm supposed to replace a pump today. And really that's led to improved environmental performance, what we're really all trying to do, right? Protect the environment. So I'm going to come across the pond to the city of Wilmington, Delaware. So Jacobs, we provide O&M services for Wilmington, Delaware, for their wastewater treatment plant, their combined sewer overflow facilities, and their renewable energy biosolids facility. I was super excited when I got to be part of a project in Wilmington where we were adding monitoring to their CSOs. That's what I'm going to spend some time talking about. So just some details about the system. The picture here is of the plant. I love going to visit the plant, and I'll admit, whenever I'm in Wilmington and I take an Uber, I say, well, you're taking me to the wastewater plant. I've had some really interesting conversations. So it's 168 mgd maximum treatment design flow, but they can treat 340 mgd maximum in wet weather with some bypasses they've got at the plant. There are 41 CSOs. 35 of those, when we started in July of 2020, were unmonitored. There's also 4 pump stations and 3 real-time control facilities with storage, and approximately 375 miles of gravity sewer. So I'm going to talk a little bit about our existing approach. When we started in Wilmington, like I said, in July 2020, our field crew was visiting all of the CSO sites, 41 of them, 3 to 5 days a week, mainly to clear blockages. But dry weather overflows can occur if the blockage isn't cleared quickly enough. So we were seeing that we're getting some dry weather overflows. You can see these pictures on the right are my coworkers at Jacobs. They're there doing these inspections every day. They're driving all day long, 3 to 5 days a week, spending their time doing traffic control when they're out looking in these manholes. So really the client, but we as Jacobs also wanted to use a modernized approach to this system maintenance that reduces risk for our employees. What we came up with was, again, new ways of working. We had a great team of myself as a wastewater collection system expert, but I also pulled in operational technology and cybersecurity experts. We had sensor experts. How did we do this to help our employees? First of all, we baked in the cybersecurity for the remote communications. We did what was called a LoRaWAN, or low power radio system, for remote communications to help us with cybersecurity. We installed level sensors in each of those 35 unmonitored CSOs. And now that sensor is connected to this, what we call our data box. At the data box, we have our radio, as well as an intrinsic safety barrier and a battery to make sure everything stays powered, as well as an antenna to communicate back to this the plant. So it comes into the SCADA system, and then we can send it to the cloud to our AquaDNA to get. Basically, what we've done is we've set now text or email alerts if the level is off trend or a sensor stops transmitting data. Really has led to proactive maintenance. And I'll admit, our goal, I should say, was 0 dry weather overflows in 2024. We have still experienced some dry weather overflows, but I've got some really cool stories to tell where we're now getting much more proactive with our maintenance. And because of this, our crew has now been able to go down to 1 day per week instead of that 3 to 5, which is allowing them to do work that they haven't been able to do for years and be much more proactive with their maintenance. So it starts with alerts and visualization. The alerts we have in Wilmington are configured for what we call above baseline. The baseline level is basically a 2-week look back. We say, okay, how has this level been behaving during dry weather only? So we use machine learning to take out any wet weather flow, any wet weather levels, and we create a baseline level. Are we above that baseline? Let's say we're 10% above baseline for a couple of hours. We'll get an alert. That's going to be the low level alert. And then if we're approaching overflow, dry weather overflow, that's going to be a medium level alert. And if that overflow is actually occurring, we get a high level alert. We've also, Wilmington has several CSOs that are on tidal rivers. So if that outfall has a tide gate, we also do a tidal correlation to see maybe do we have a broken tide gate. Then we also get alerts if the sensor is not responding for several hours. We do show wet weather alerts on the dashboard, but they are not sent by email or text because, yeah, our operator does not want to get 41 alerts during the rain event. He knows those things are overflowing. He needs to be able to go to the dashboard and see where's his worst problem. So this is the dashboard. This shows the city of Wilmington, as well as we have pulled in our online GIS, so we can see kind of where we are in the world of sewers in Wilmington. And you can see that we show various sensors that we have out in the system, as well as where are the real-time control facilities? Where do we have our level sensors? Where do we have flow meters? And we have a status. So green is no alert, all the way up to red with the high level alert. So I'm going to show a couple of, just in my mind, really kind of cool things that we've been able to tell. So at CSO 6, which is on the Christina River, we actually had the baseline level was increasing, and we had a couple of rain events. And after the rain event, the baseline level, or the level was starting to really, really trend above baseline. So we said, oh, okay, let's keep an eye on this. Let's see what's going on. Well, it started to trend much further above baseline. It looked like it was getting close to an overflow. So we sent our crew out. They rotted out the manhole, kind of looked around, didn't really see the blockage. The level went down very quickly, but a couple hours later, it was right back up. So we sent the city crew out to jet the sewer. We figured out the blockage is somewhere downstream and it's starting to surcharge. During wet weather, we must be getting more debris collecting. So we jetted the sewer. After we jetted the sewer, we went straight right back down to baseline. And it was really cool to see that data. Unfortunately, I forgot that slide, so I apologize for that. But I do have a couple of other examples here where we've been able to clear blockages before they become overflows. So this shows what this looks like. So we have our depth view where we have the green line is our real-time data. The gray line is that baseline level I was talking about. And purple is whenever we've had rain. So you can see again here at CSO 24, and then one of the other CSOs, sorry, I blocked what that is. That green line was trending above baseline. So you can see we had an above baseline alert. We're like, okay, something's going on. We started watching. We're below the overflow level. We're still doing okay. But we were able to go out. CSO 24 actually required confined space entry. So we wanted to make sure this was really rising for a while. Like you can see, this is a few days. We let this go for a few days, but we could see this is trending up. This could turn into an overflow. So we did send our crew out there to do the confined space entry and clear the blockage. They were able to find it very quickly, clear it, and then boom, we went right back down to baseline as I've got circled in blue here. Similarly, at the other CSO, same thing. It's trending up. This one they did not, happily, did not have to do confined space entry. They were able to see the blockage and clear it without having to get down in there. And we went, boom, right back down to baseline. So this has been super helpful for our CSO maintenance crew. And now we're able to say, with this eyes on the system, as we call it, we can see when the level is going up. Our operator kind of jokes around with me. He says it's like he's eating from the poison fruit of the tree of knowledge. Now he knows much more about the system. He's not sure if he's happy or sad about that, but it's really been helpful for us. And now we can look forward to that goal of zero dry weather overflows in the future. So I'm going to kind of switch gears, still in Wilmington. So this is what Wilmington looks like. I had the dashboard. I'm going to walk back. I have this dashboard. This is what Wilmington looks like on the map. This is what Wilmington's sewer system looks like as a schematic. These orange diamonds are those 41 CSOs. They have 5 interceptor sewers that are shown in different colors that then all come down to this 11th Street pump station, a terminal pump station that then pumps to the wastewater treatment plant. Like I said, we operate the wastewater treatment plant. The city of Wilmington contributes this flow to the wastewater treatment plant. However, Newcastle County also sends flow to the wastewater treatment plant. We have no control over that flow coming into the plant. So we wanted to know, how can we better look at this as an integrated system, the collection and the wastewater treatment plant as one system? Of note here are also these 3 storage facilities, these 3 real-time controls with storage. Those are very key to us to say, can we look at a storm coming up and see how do we operate these facilities to maximize what comes down to the treatment plant without overloading it and minimize our sanitary sewer overflows as well as our combined sewer overflows. So first thing we had to do was skeletonize that hydraulic and hydrologic model. So this is basically showing that skeletonized model, showing our interceptor sewers. Now we have this workflow that we can go through. This is where we're doing some really neat machine learning in my mind. And this is something I've been dreaming about for about 20 years, I'll admit, is we can now say, hey, I've got real-time data coming in. I can use that to help with some compliance reporting. I can help with annual reporting on CSOs, and I can automate those processes. I can also use that real-time data to calibrate my model. At Jacobs, we have an automatic calibration tool that helps us to run this very quickly. So we've run 2 years of data to do this initial calibration, we're calling it. Then we can take the weather forecast. We can take the forecasted rain, the forecasted tide, bring that into what we call our optimized model. And we can also feed in our boundary conditions from our wastewater treatment plant to say, oh, I've got influent flows coming to the plant from the county. We have a data-driven model for those county flows that'll say, oh, okay, with this storm that's coming up, my county flows are going to be X. My city flows, if I run it through my hydraulic model, are Y. How does that compute with the capacity of my plant? And what decisions do I need to make out in the collection system to help operate the plant as well? Out of that, we then get a real-time control recommendation. So we'll say, oh, for this specific weather event that's coming in the next 24 hours, I'm going to put this onto the dashboard and say, these are the set points I need to run at those 3 storage facilities. Mr. Operator, can you change the set points? So it'll send a text or email to the operator with those optimized set points. Additionally, we've also envisioned where you could use this for climate change impact. You know, can I take future rainfall? Can I take sea level rise? Run that through this for future storms, future groundwater infiltration. How do I look at how I'm going to operate my system 5, 10, 15 years down the road as climate change is happening? To me, this is just amazing. So how does it work? So we have this set up. This is my same AquaDNA dashboard. Oh, I can see I've got, within 24 hours, I've got 1.2 inches of rain in the forecast. So I click on this as the operator and say, oh, okay, what does this tell me? I've run the model. Once I've run the model, it gives me outputs. So on the left, you can see that this gives me some set points. It'll say, oh, set this gate over here to fully close, this one over here to fully open. And it'll say roughly at which time to do that. And those optimized set points then help us to, like I said, maximize what comes down to the plant. One of the other cool things that we saw with this is this also, we can look at this as at an asset level. And what we found, there were some pipes that had flows. We had this weird kind of flow spike. The rain's coming in, the rain comes in, it comes back down, and then we had another weird flow spike. Let's just see, are there just some anomalies going on in our system? And how do we better operate it to prevent those spikes? So with that, I'm just going to end with a few conclusions here. I mean, what it comes down to is utilities really are experiencing greater challenges that lead to using digital solutions. And our condition assessment, asset management, and risk assessment in your collection system really can all be performed more efficiently with digital solutions. we have more data than a human can ingest and visualize. But with these digital solutions, we can do our jobs more efficiently. And lastly, it's really that these AI and ML tools can assist visualizing data and providing insights into the condition and behavior of your collection system. And with that, I'll open it up for questions.
Thanks, Jen. We appreciate you talking about this and really actually quite fascinating stuff. We have questions rolling in, but I had a couple questions as well, so I wanted to start with those, and then we'll see where things go from there. But the first thing I wanted to point to was the CCTV stuff, and you said that like that coding, it becomes a backlog. Why is that such a big challenge? Like, what are some of the drivers that you are seeing in that regard? Like, why is CCTV coding becoming a challenge? Why is it an inaccuracy thing? Is it literally just there's too much work to do? Like, what's going on there?
It's a little bit of everything. I'm gonna pull up, I did have actually a little bit of a backup slide for this as well. So one of the things we did was like, how much time does it take to do CCTV video, including the defect coding? And it's like, oh my gosh, when you look up how it all adds up, you have mobilization, recon, you do the cleaning, you drive the robot through, you do the data coding, you extract the data, you extract the tool, you demobilize, might have to spend some time repairing the robot, then you transfer the data. Then you send it to the office engineers and they do a QC review of the coding. But all the end of this, that cumulative total time is 12 to 16 hours for 1,000 feet of sewer video. So like I was saying at the beginning, utilities are they're out there inspecting their system about 10% of their system a year. So I think what I said, Wilmington was like 385 miles. That's a lot of time
A
if you
lot of
inspected
sewer.
10, right? 10% of your system in a year. And what we really found was that our Dragonfly tool could reduce that total time by 30 to 40% by reducing some of that 1.5 to 3.5 hours that they spend, the field crews spend doing the data coding. If they can focus on driving the robot and not having to stop, do the coding in the field, that's going to save some time. Additionally, it definitely saves time in the office, that 2 to 3 hours that the office engineer is spending doing that QC review. So what we really found is that, it's almost impossible to deal with the amount of CCTV data that's been collected over the last probably 10 to 15 years. And utilities we were talking to were just like, we can't keep up. So that's really kind of what led us to this tool.
Yeah. Well, you kind of answered the next question that I was going to ask from what people said here, which is how long does it actually take to process this video information? And you're saying that, like, for instance, on this slide, you have the 6 to 8 hours or whatever for data coding, and then around or that's the cumulative, sorry, 1.5 to 3.5 hours for data coding, about 2 to 3 maybe for QC review coding, and that Dragonfly could reduce that by 30 to 40%. So you could be looking at only 2.5 hours, for example, for that data coding rather than at 3.5.
Exactly. Yeah. We do our own QC, obviously, of all of the results from the AI tool. So we do our QC on that, but we do expect that our clients are going to still be doing some coding on their own, or also maybe do some QC review of what they get from Dragonfly. So we realize there's still going to be some time. We can't save all of that time, right? But it does help save that. That's still a good chunk of time that a city's employees or their contractor can save.
Oh yeah, well, it all adds up, and and this is just saying for only 1,000 linear feet. When you extrapolate that out over the course of an entire system, like you're talking like hundreds of hours in some cases that are saved.
Oh, for sure, definitely, and that's one of the things we've really found, that using AI with CCTV coding was, to us, it was like, like we were teasing the junior engineer that we hired last year in the Knoxville office. Oh, now you don't have to spend hours watching video. You can just run it through Dragonfly. Oh, lucky you.
Yeah. Well, you mentioned the QC thing, and that leads me to another question here, which
Yeah.
is the quality controls that are in place on this. It sounds like you guys are doing some QC on your end. I would imagine that's feeding back into the AI itself as well for it to kind of learn on top of like what humans are finding. Is that one accurate, what I've just said? And then two, how accurate have you found Dragonfly to become like time after time?
So yes, that is very true. We have NASCO PACP certified inspectors who are doing a
Hmm.
QA/QC on the results that come from the AI tool from Dragonfly. So they're part of our Dragonfly team. They're part of the service that we provide with our Dragonfly tool. So you know, we want to make sure that we as Jacobs are providing good data and good defect codes back to the water utilities that we're working with. And so I, what we found is that, we've trained the tool on over 10 million linear feet of CCTV video. It's working really well on probably like the top 40 defect codes. It's when it gets
Hmm.
into the more uh, kind of like the rat in the sewer, things like that.
Okay.
It's not going to necessarily know what that is right off the bat. So we do have to have that human QC at the moment. But yes, the QC comments basically that are made by our reviewers then get fed back into the AI tool to help train our AI models for sure.
Okay, cool. So it is like it's learning, which means it's been getting even more accurate over time. And I would suspect over a long enough period of time that it will start to identify that atmosphere appropriately.
Yeah, exactly. Our expectation is that, the amount of QC that our inspectors need to do is going to also decrease over time because the tool is going to become more and more accurate as it goes along and as it learns. So I don't
Yeah.
know exactly like a percent accuracy at this moment in time, but it is increasing as we get more and more data
Okay.
coming.
Yeah, and then just kind of to that point of like the less work overtime for this quality control stuff, I could imagine there's some field crews who might be concerned about this like taking away their job, so to speak. And what are the concerns related to that? So, I
Yeah.
mean, in my mind, I see this as an opportunity for them to have repurposed work that has an even greater impact. I would imagine that you kind of think of it in the same way. How have you seen utilities approach this subject? Because I'm certain that that's a concern for some of these field crews.
Oh yeah, we've been grilled. I'm not gonna lie. Yeah, we had people say, "Hey, are you trying to take my job? Or are you trying to take my field crew's job?" And our answer is no. In fact, a lot of utilities, like I said, you're trying to get to 10% of your system per year so that you're on that kind of reinspection cycle. But it's hard to get to that goal. So, we're really saying, no, we're not taking the job away from your crews. What we're doing is we're enabling them to be more efficient and possibly get more done.
Hmm.
The same thing with our AquaDNA solution that I was talking about in Wilmington. We had that discussion with our CSO crew lead. We said, "Hey, are you ready to go from 3 to 5, 3 days a week down to 1 day a week?" And he kind of made a face like, "Oh, I don't know."
Hmm.
And then our other, one of our other team members in Wilmington said, "Well, yeah, but Matt, if you can, you know, if you can go down to 1 day a week, you'll be able to do this, this, and this, and this, and this." And he was like, "Oh, yeah, okay, yeah, we'll give it a try." They're still skeptical, obviously, but what we're
Hmm.
finding is, I mean, as it's harder to keep staff, as it seems like we end up getting more work with less staff. So I really don't see this ever replacing people. It just
Hmm.
helps us do our jobs better. I call it kind of the digital assist, if you will, because I'm like, yeah, we're not taking people's jobs away ever, I don't think. It's more, how can we be more efficient and how can we take some of these just more sort of things that are more like rote memory or just repetitive
Hmm.
tasks, use AI to do those so we can use our brains for the bigger problems, right?
Yeah. Well, I like that you mentioned that too, because that also, you said it's not rote memory. That to me is a big signal of like, oh yeah, this also is something that allows for younger folks to enter the industry with less of like a ceiling they have to reach for, because it does, or I guess it's actually the floor is lower, it's not as high. It's really the way to put it, right? The ceiling is still there, it's the floor that's lower. So I think that's commonly a concern. I think that a lot of utilities do run into, of like, oh, we have these people who've been doing this for 30 years and it's all up here. It's like, how do we capture that? How do we put that into something that can be distilled for someone who's 3 years into their job here with this utility? And this sounds like it's a good opportunity to like bridge that gap.
Yeah, and we've been able to, we have another solution called Replica where we can do operator training. We can say, oh, okay,
Oh,
we built a digital twin of your wastewater treatment plant, let's say, and now we can use that for operator training. So you have this younger operator coming in, instead of having to fiddle with dials and possibly create an upset at a plant, they can check that, they can run scenarios, they can see what's going to happen if they change that dial. So
mhm.
it's been really cool to see how these digital solutions are helping, lower the floor. I definitely can see that happening for sure.
Yeah. You mentioned like the high priorities, right? This is identifying high priorities. What about the inverse of that, where you have the lower priorities, right? Has there ever been a discrepancy that you've witnessed where where the manual process may have identified something as being a higher priority than what the AI did? And did that actually save time in the end of being like, wow, we actually didn't need to put that as high of a priority as we thought?
I don't have the anecdotal evidence of that, but I would say very
Okay.
likely, yes, we've encountered that where we've like I said, we may run into where the manual coding has used a higher structural grade or coded that defect as a different type of defect than we did, where we'll say, oh,
Mm,
actually, and we have found where the manual coding has caught things that the AI didn't catch.
yeah.
And that's again something that we feed back to our AI tool. We're like, hey, you didn't catch this. Let's look back at
Hmm.
that. So yeah, definitely we have found things where, yeah, you're gonna change the priorities. I would say either increase the priority or you could have some where you decrease the priority as well.
Yeah, and that just allows you to better prioritize overall. Because if you're thinking that something's a higher priority than it actually needs, you might be investing your money in a place that it doesn't need to yet.
Yeah, exactly. And one of the cool things that I like about it is, you can download the data and then put it in your GIS, which to me is great because then you can visualize it and you can
Mhm.
say, oh, okay, now I know where my priority areas. And maybe I have like 3 pipes in one geographical area. That could help me create a capital project that I need to go send a rehab crew out, right? So
Mhm.
it's really impactful to see everything on the map.
Yeah. Oh, that's a great comment too. I hadn't even really thought about how it's just like, oh, if we see these all clustered together, why don't we just do a capital project on that, right?
Yeah.
It's like, oh, it's that makes it makes for a good case, especially to a county board. You've got all the data to back it up too. Well, anyway, thank you so much, Jen. We appreciate
Yeah.
your time. This unfortunately will be the end of the session. For those questions that we didn't have time to answer, we will get back to you via email. Just as a reminder that at the conclusion of this webinar, you will receive an email with a link to download your certificate, which you can use for Stormwater University or for one professional development hour for attending the webinar. That concludes today's presentation. Once more to Jenn, Dr. Baldwin, thank you so much for being here and participating in our event. We'll take a short 15-minute break right now, but don't miss the final session of today, a conversation with Gary White. He is the CEO and co-founder of water.org and Water Equity. Thank you so much, and we'll see you later this afternoon.